first, let's talk a little bit about the typical test activities that you'll find in a DAS deployment, and they're also most of them are very applicable to small cells. We're going to do a kind of an overview of this. We're not going to spend a lot of time because we want to get down to some details about the new tool. So here's kind of a picture of the life cycle that if you're involved in this industry at all, if you've worked in it, you're kind of familiar with everything from the planning, the design process. You build it. Oftentimes, that's farmed out to construction companies, and then service companies get involved with helping the testing of it. You go through the integration, and of course, once it's launched, there's optimization involved. But during the course of that life cycle, there's a number of places where you're in the field doing testing, actually making measurements and collecting information about how well the network is doing, particularly from an RF perspective. Let me just go through these real briefly. So initially, like when you're in the design phase, you're going to do a baseline survey. This is required in order to completely understand what's there before you start your design. Sometimes it's focused on a network. Sometimes it's focused on all the networks that are available. It can and often does include Wi-Fi. But basically, it's really trying to get a good picture of the signal levels, the signal quality, what kind of interference you may be having. So it will be the critical input to the design phase. Oftentimes, during that early design work, you'll do a CW test, a continuous wave test, and that's really for the purpose of finding out, getting good input into your model. So a lot of the tools like IBwave, which we'll be talking about today, and other tools like that, they actually allow you to bring real-life measurements in to help tune the model so their predictions of how your plan will perform is better. So that's often done during this stage as well. And then, of course, these next ones have to do with after you or through the course of building out your network. For instance, after the initial antennas are deployed and all the connecting, the fibers and the coaxes and all the head ends and repeaters and amplifiers, one of the first things you'll do is what's called an uplink and downlink test. Okay, so that's actually going to, before you ever hook up your network base stations, you're just verifying that all the installation was done well. Is everything connected well? Have you created anything that's going to cause noise? Is anything misconnected or things like that? So you do an uplink test and you do a downlink test. And then oftentimes you'll also do what's called a coverage test at that point. So if you just put a test signal in at the head end, you're going to try to make sure that the propagation of those signals and the footprint of those signals really are going to match what you thought you were going to achieve during the course of your design. And of course, if you see any discrepancies there, you're going to maybe make some adjustments to your design. So those are the two things that are kind of done after the DAS system's deployed. But the next step, of course, is now you've hooked up your cell site equipment. So you're going to do some commissioning, and there's several phases of that. You're going to check the levels of the cell site equipment, the base stations, as it comes in to the equipment room. You're going to then also check to see if that's propagating well out through the system, as well into the coverage area. As for a downlink, you'll do an uplink version of that that also checks it coming back. You'll do additive noise tests, those types of things during that stage, right? So that's really kind of before you're ready to say this thing's ready to deploy. And then, and that's usually referred to as commissioning and integration, and it's focused on the network equipment after it's installed. And then lastly, of course, is now you're ready to go live with the network. So you're ready to do some full integration tests. That word's used again oftentimes. You want to do a baseline. Okay, how is this network performing? So compare that to what you had before. You compare it to your design to see if you really achieved all your design goals. And then actually you have a permanent kind of a snapshot of where you were. So those are the kinds of test activities that are fairly typical across DAS, and many of these apply to the small cell deployments, whether you're indoor or outdoor, in building, campus, all those types of venues. And the next thing I wanted to kind of summarize or focus on just a little bit is the types of testing that you do and how they apply to each of those activities. If you've been around very long, if you're an old guy like me, you know, life started with outdoor, you know, macros and drive testing. But, you know, 15 years ago or so, a lot of the traffic started to move indoors, so special tools were developed for in-building, for indoor walk testing. And, of course, you know, there you'll see, particularly as I've listed some things that are particular to the activities I just mentioned and how they apply to DAS and small cell systems. So, for instance, if you're doing a baseline survey, you're doing a walk test tool. If you're collecting the data you need to do model tuning, yes, you're going to be walk testing. And certainly near the ends where you're doing an integration and a baseline benchmarking, you're often not just using scanners, but using test UEs as well and an integrated test tool. But what we did notice, and we'll get into this more in a few minutes after the introduction, is that a lot of the times those types of tools were used where really the requirement was not a continuous walk, but more what we call spot testing. Oftentimes it was to verify the antenna system. So I referred to the downlink test earlier that you would do once you've installed all the DAS equipment. So that's actually something people just tend to walk up underneath the antenna and test. And then when you get to the commissioning stage, there's a couple of other types of tests like that. The downlink test, where you're out underneath the antennas. There's an uplink test that you need to do. You need to look, and a lot of this time you're in the process of setting levels, attenuation values and things like that. So there's testing that's done both underneath the antenna, or you're in the head end and you're walking up to patch panels. And again, it's kind of spot test oriented, right? There's nothing walk test about being in the head end. But even out in the end, under the coverage area, a lot of these tests can be done more efficiently by just testing at the spots underneath the antenna. Okay, so that's kind of what we're going to focus on in just a few minutes is the uniqueness of that and what kind of tool would best suit that type of application. A fourth type of testing that's often done, particularly with DASs, is using spectrum analyzers or signal analyzers. If you're doing spectrum clearing at the beginning, just to make sure you know where all the free signals are, SpecAn's perfect for that. Oftentimes these uplink tests that we referred to once you've installed the DAS, they're looking for noise levels, the noise floor, additive noise, those types of things are really done well with the signal analyzer. And it really helps to have those tools totally integrated, which is something that we saw was important and have also done. If I have some time at the end, I'll touch on a little bit of our signal analyzer and how it's tightly integrated with our walk test and our AVT. Commissioning, troubleshooting in particular is other places the signal analyzer becomes important. Okay? So you don't have to spend much time with the guys who do this type of work to understand the value that you can gain, the efficiencies that you gain in your process by having a very tight integration between the tool you use to design with and the tool you use to collect and measure with. So we've worked for the last few years with IBwave, much like many of the other collection tools, but we've really focused on the unique value that a scanner brings and the types of measurements it does, and use that to kind of drive the value of integrating with a test tool, with a planning tool. So I'm going to walk you through how this works if you haven't ever used this type of tool before. So IBwave, of course, has a PC-based design tool, and that's where you do most of your design work. And they have the ability to export that design in a couple of ways. One, via the cloud, you can download it to your tablet to an application they have called IBwave Mobile Note. And that brings the design down to the tablet. So now that you can go out into the field, you have all the information that you need there. You actually can add information about your design, things like that, to send back to the main tool. But you can also, if in those cases where you don't have Mobile Note installed on a tablet, you can actually export that to a file that can be hand copied over to a tablet for use in the way I'm about to show next. So once you have the design down on the tablet, IBwave created this very easy-to-use capability where one touch will actually launch a collection tool. and pass the design information over to the collection tool. And that's what we've done. We've integrated with that as well. So you can see that both from mobile note, if you have that on your tablet, you can open that right up into the application called SeeHawk Touch, which is our collection tool. So basically it makes it really easy to do this process of being able, as you're walk testing or antenna verification testing, you have the full set of information that's part of the design. And you can have that for reference, and actually you can start to build things into your collection tool that does automatic checking because you have that information. And what we've found is many of the people who are out in the field doing the day-to-day collection, the walk testing, aren't necessarily always going to have that automated process of using Note. Now, there's a lot of advantages to that. It's all automated, it's more time efficient, less errors, all that kind of stuff. But if you don't, you can actually, like I said, export it to IBWC files and open it right in our tool. In fact, that's what I'll demo here in just a few moments. Okay, so now you have all that information available while you do the collection. Once you're done collecting, a simple touch of a button will actually send that back to IBWave Note. So if you have that installed, it's automatically brought back in. You can see that any walk testing, I know it's probably a little hard to see, but you can see all the measured points now show up in IBWave Mobile Note. Not to fear, though, if you want to get your measurements back into your design tool, you can also export it back to IBWC file, hand carry that over, and then, of course, with either of those methods, you can get it back into your original design. Now, in reality, this cycle actually is done multiple times. So you think of the baseline testing. You might start with your map, your floor plan and design, bring it over to our tool, collect the baseline, pass it back. And then once they've done some of the design work, you pass that one more time back over the collection tool, and that's where you can do some of the antenna verification testing, uplink, downlink, those types of tests. And actually, IBWave has a way to handle these sets of measurements that are done at various points in the life cycle. So you can do comparisons to say, what was my baseline at the beginning versus the end? What was my predicted value versus my measured value? So in truth, you actually may go through this circle of bringing the fresh information back and forth 3 or 4 times during the life cycle. But it's automated, it's very effective, and it really provides an important part of being able to do the measurements well by having as opposed to a printout piece of paper, you have it all right there in front of you on your screen as you're doing the collection. Now, I kind of went through this fairly quick. All of these topics that I just covered in summary, we actually have a 2-hour seminar that we've done with IBWave that actually goes through a lot of these things in detail, talks a lot more about why you do each test, what is included in each test, and what's important to pay attention to as you go through that life cycle. There's a YouTube link here that will get you to that first hour, and you can actually find the second hour as well. Okay. All right. So now when we've kind of got this as a framework for getting a lot of the major test activities achieved, but there's a few other aspects about it that over our work over the last year and a half or two with our services group, as well as several of the major operators in the U.S. here, has highlighted some of the most important aspects of this could be actually having the transmitter information included in what comes over. So as of last fall, IBWave now started including all the transmitter information to be exported out to the collection tools. And it's really important, if you're going to depend upon this information during your collection cycle, to have it up to date. But what we found is oftentimes, because of the workflow, some of the work hasn't even been completed in the design, but you need some of that information during the collection process. Oftentimes, things aren't built according to plan. So what was important about this process was to be able to actually make that transmitter information as complete, as up-to-date, and accurate as possible. So here you can see that it's a little bit different picture, but as you bring the information over as part of the design, we actually create a little database of this transmitter information to have available. So now when you're in your collection, you can see all the transmitters, If you want information about what, what cell site, what channels, what PCIs, everything from tilt, all that stuff is there, is available. But we also provided a manual editing capability. So if you out in the field and one antenna is moved, you can move it. If an antenna has been added, you can add it manually. And the whole goal of that process would be, as you're doing your collection, you want your transmit information to be as up-to-date as possible, as accurate as possible, and actually at the end create an as-built kind of record of. Now, a lot of that work could be done in Mobile Note if you had it available. If you don't, and you just do the file, it actually produces a new file. We found, like I said, that many times a lot of the people doing the collection work don't necessarily have access to Mobile Note, but they do have access to the IBWC files. Now, a couple of things we're actually thinking about in the future that we think could actually help complete this, and we're working with IBWave on doing this, is one, you could import information that comes from the network that SON is updated, so changes that were made. So now you've had it accurate in that way. But the other thing is taking this as-built information and importing it back. So that's one of the things we're debating and considering whether that's of value to do. So essentially, and I'll go demonstrate this in just a moment, but now you have the ability to edit and have a complete update set of information. Now, onto the spot testing requirements. So there's a couple of things that we started to hear about. So, and I've witnessed this at least 20 times over the last year. Go out with a team of people. They typically send 2 people, often, one guy with a measurement tool, one guy with a piece of paper, the map printed out, a list of all the transmitters, and they go stand underneath each transmitter, and the guy calls off the numbers and he handwrites them down, goes back to his office and puts his stuff in spreadsheets, so something like that. So we were asked, can you help find a tool that will kind of be fit to that type of work? We want to be able to verify the construction, installation, configuration. We want to be able to have something that's useful in the coverage area as you're standing in the antenna, but something will also work when you're in the equipment room. So you want to be able to address both of those types of work functions, and something that automatically create documentation that's of the style that we're used to doing. So creating an Excel spreadsheet that has the right types of values, information about the network plan, and the corresponding measurements that were made. But more important than just the features and the functions were some of the goals of how this would help address the process. You generally want to get it down so one person can do it. You want to cut the amount of time down. More importantly, you want to have fewer errors, right? And you want to be able to assure that the people have actually done the work, which actually becomes an issue in some cases. What was important about this was if I have equipment already in my kit for doing walk testing, let's use that if at all possible. Let's not have to have extra equipment, those types of things. So utilize that imported information, so let's leverage that as much as possible. And in fact, that leads to the next one is analysis. Is there any kind of analysis you can do that will automatically compare what you measure versus what's in the design to kind of give us hints as to what's going on? So that was important to build in. Automation was key, and we actually had these competing priorities here from all our gathering of information. One is, oftentimes, there's less skilled guys that are out running around the field, out doing the collection. You want it easy to use and hard to screw up. On the other hand, we've sent our experienced guys out. If you can do anything to make it possible for them to get more done in that visit, if you can highlight problems that they don't have to wait till the information's back in a post-processing tool, can you highlight some of the issues that the testing then covers so they can actually do their work there in one visit as opposed to having to come back? And of course, at the end, you want a standardized process. So everybody on the team's using the same set of design guides, the same types of measurements, the same reports, and across multiple teams in a larger net operator like Verizon, AT&T, the big ones, Sprint, T-Mobile, everybody actually. Okay, so that's kind of what we use to kind of guide what we're doing. Here's a brief picture of what the tool is, but I'm going to switch over and to go into the demonstration for the next 10 or 12 minutes. But essentially, you'll see that now that you're in the collection tool, not only is the map there, the floor plan, but all the antennas are available for information. So give me just a moment. I'm going to switch over to actually bring up the software. All right, so this is a picture of of what's called SeeHawk Touch. It's to illustrate. So you can see that it's already got a list of scanners up, and I've selected one. So we talked about the two methods of bringing the design information into the collection tool to have available. The one I'm going to demonstrate today is the ability to load the file that gets exported from IBwave. I'm going to pick the one that's actually called Woodfield Mall. If you're from Chicago, you're familiar with this. And you can see a little bit of information comes up about the IBwave design, so it's traceable back to the design that was done in their main design tool. And so here you see a complete list of the types of floors. If there were multiple buildings, they'd be listed here as well. And you can select one floor at a time, do the work on that floor, and then actually go back and forth and get all the floors or all the buildings done while you're within the collection tool. You have a record on the right of kind of the previous work you've done. All right, so here's where you set up scans. Now, I'm not going to go through all that. We do have other training materials on that. But just to show you, in this particular, for this demo today, I've set up 5 scans. And what's really important about the scanner use for this type of work is that one device can measure all of them at one time. And that's really critical to get the time efficiency for this type of activity. So you can see we're going to measure all 5 of these channels simultaneously. A couple of LTE, 3 widebands, okay? So that's what we'll do. And what I'm going to do is switch from indoor mode to what we call our antenna verification mode. So all this is really tightly integrated. So you can go back from walk testing to the antenna verification testing tool very quickly and easily. So essentially what happens when you start this is you get a chance to kind of tell it what you want to call the spreadsheet that you're going to have saved that kind of provides that end documentation deliverable that you want at the end. And so now you can see that the floor plans come up. I'm going to zoom in just a little bit. First, let me show you a few things on the left about the transmit editor that we call it. So for instance, you can click one button here and it allows you to add, if you click this second icon, it allows you to kind of add transmitters. So let's say you're out in the field and you realize that the install guys put an extra antenna. So they put it down here, just outside, wherever, right? So you can also go back and delete that one, right? So you have all these capabilities to kind of edit them. But more importantly, the most powerful feature of this is you can take the plan, and if it wasn't complete or accurate in any way for the antennas that were installed, you can change everything from azimuths and tilts and orientations. So you can actually add channels. You can change the channels. You can actually put all the information about the PCIs, the cell IDs. All that information is readily available and easy to access, and it's also completely editable to kind of update your design file if it was in any way incomplete or inaccurate. All right, so that's the transmitter editor. It's very simple and straightforward. There's another one for moving. And, of course, once you've made any changes, you'd save this. So it's completely available. So the next time you came into your collection tool, it's available. You can always relook at it. And this is the one we're talking about at some point, working with IBwave to see about integrating, importing it back into their tool. All right, so now when it comes to actual the performance of the ABT test, like I said, it's relatively straightforward. You click on one antenna, turns it yellow, and you hit the test execute icon. And what you'll notice happens is we actually bring up this pop-up box. There was an interesting thing about working with the guys who did this. You'll notice that those middle columns give you real-time values. So if you were kind of moving around a little bit under the antenna, they'd be going up and down. But on the right-hand side, we actually capture the maximums. If you're out under antenna, the goal here is to find out is the maximum power delivered to that antenna coming out at the level you expect according to the design? Now, ideally, you'd be connecting the antenna, but you're 6 or 10 feet underneath it, so that's not happening, right? So what you're trying to do is actually, oftentimes we see the guys have to move around a little bit so that at one spot you're capturing the best 850, and another spot it's the best 700, and another spot it's the best 1900. So we allow you to kind of mimic that, you know, execute that kind of, someone called it the RF dance, but basically allow you to kind of capture those maximums so you're getting the closest measurement to what the maximum is coming out of that antenna. And of course, once that's settled down, you can add your report. Now, we do a couple of things with that. First thing is, you'll notice that at the bottom, we added 5 lines, so they've all got the same transmit ID on the second column, but one for each of the measurements we made. Now, another interesting thing is that we actually brought over from the design the planned PCI value, which you see in about the 5th column, and then we also tell you the PCI of the best server. Of course, if you're in an antenna, you better be getting the signal that was designed to go to that antenna, and it better match. But we also do some automatic checking for you. So if that antenna that you measured actually had a best server that was other than planned, we highlight it red, and you immediately know there's some kind of a problem. So, and essentially you just can go, you walk under an antenna, you spend about 10 or 15 seconds under each one. You know, once you're happy with the maximums, you've added it to the report, it's really pretty straightforward to kind of get that and get walked on. So it's something that one person can do. It's something that you can do very quickly. We watch people spend 3 or 4 minutes on their antenna as opposed to 10 or 15 seconds now. So really it's very easy to execute, so you don't really have to have a high-skilled guy, a high-experienced guy to go out and do this. Now, in addition to this table we add at the bottom, we actually are also starting to create what we call a graph. We actually have 2 versions, one that kind of focuses on the power levels, so RSSRP for LTE, the corresponding EC values for wideband CDMA. And so basically what happens is every time you execute a test, we add it down to that table report as well as this graph. And so we also do some automatic checking here. So what you do is we calculate the average. So once you've gone through tested 20 or 30 antennas, you start to see if there's any that are outside that average by more than the standard deviation. We highlight it in red, okay? And like I said, you basically, you have that there to kind of indicate to you that there's a problem that you need to go investigate. You can also, so right now we're showing the wideband CDMA 1900, but you click on this blue bar and you can pick any of the other 5 channels that you're measuring. Right, so now we've switched over to the 700 LTE RSSRP. We also have another one that kind of shows the signal-to-noise ratios. So for LTE, that's CINR. Another nice thing we do, a lot of times people like to say, what's the average values from zone to zone or cell ID to cell ID? And so we actually, in that same control mechanism, you can average by zone. So in this particular case, the antennas I measured is over 3 different zones, so now you can kind of see the zone averages, the mins and the maxes as well. Okay? So these are some of the kinds we've tried to build in to do some automatic checking. We're actually going to start, we're working on trying to import the expected value, expected power values that come out of the antennas, and kind of actually look to see whether they're within the range of what you measured as coming out of the best server under each antenna. Now, let me just see. We also have like the ability to look up stuff as a table view. So here's all the antenna listed in a table format. You'll see that each of the tests that I've already done, it kind of shows, on the icon that was green, they match up here with the table. Also from the same table, some of you can get access to all that same information we showed earlier, where you can see the channels, the site IDs, cell IDs, all that information is also available here. So again, what we found was very valuable is trying to get all this information available to you during the collection process, try to get as much done while you're there, to do some of this automatic checking, know what to troubleshoot while you're there on site, as opposed to having to go back to the office, analyze it, and come back. Okay, now I'm going to kind of switch back over to the slides for just a moment and show you one more thing about this. We've also found that this is very useful in the head end. Oftentimes, you're going up to a patch panel with a series of ports on it, and you want to make the same measurements on the patch panel that you're making, of course, out in the antenna. So the same list of channels and cell IDs. So we allow this, you have to take a picture, photograph, drawing, whatever you have of your head-end equipment. You would take these icons and kind of create one for each of the ports you're going to test. And now you can do the same kind of simple execution where you tap on an icon, run it, and then once you're done, it creates the same kind of table below. Now, in addition to the table that's created, we're also automatically creating a CSV file that can be used in Excel. That CSV file is completely customizable, right? So you can go through and say, I'm interested in all 50 measurements that a scanning receiver will give me, or I'm only interested in RSSRP and CINR, you know, the power level, the signal level, and the signal noise. So you can put it in different formats that you want. So we're trying to make this relatively straightforward to take it and make it look like the documentation you're used to producing by hand when you're going through this process before you have an AVT tool. Okay? Now, the last thing I want to touch on in the last 5 minutes before I stop for questions is clearly people use signal analyzers quite a bit in this work, particularly with DASs. So one of the things that scanning receivers have available in them is a full spectrum analyzer. And so what we've done now, we've created a tool called a signal analyzer that actually measures the full spectrum, as well as done the typical scanning, decoding type measurements that you're used to with a regular scanning receiver and any collection tool. And this is all tightly integrated. So it allows you to, with one or two touches, to go back and forth between your walk testing, AVT, and signal analyzer. So if something shows up in AVT that doesn't look right, then you can go back and forth to this. This tool is also used oftentimes in that uplink test where you're looking for noise floors, you're looking at noise levels, additive noise as you turn on all your remote units. And again, it's all packaged right there together using the same scanner, the same tablet, the same application. And it really leverages the investments you have, as well as, you know, creates a much lighter, easier to carry kit, and easier to get back and forth between those things. Now, this signal analyzer doesn't necessarily replace 100% of the times you'd use one, but hopefully 80 to 90% of the time you won't have to bring the bigger piece of equipment out of your truck unless, you know, there's extra items you're trying to investigate. So give me just a moment. I'm going to switch back over to the live screen and show you kind of how it's integrated with our tool. So I'm going to hit the little back button to kind of get out of where we're at right now. I'm going to stop the test. I'm not going to save those transmitter changes I made. So right up here at the top, instead of going into one of those indoor walk tests to an antenna presentation, you hit this little icon up at the top, and you'll see it immediately comes up into the spec-an mode. So you didn't have to reconnect anything, you didn't have to recable anything, you didn't have to switch applications or pieces of equipment. It's all available. Just a couple minutes on this capability. So you can see I'm in what's called frequency mode. And there you set everything up by knowing what frequency you want to look at. At this time, I've set up for the Wi-Fi 2.4 gigahertz band, kind of centered at 2450. You can see the Wi-Fi signals here in my local office coming on and off. You can change the span. You can change the resolution just by editing things like this, right? So it's very easy to use. It's got a lot of these capabilities that you'd expect to get from an Android application. Now, what I'm going to do is show you something that you can't tell what I'm doing, but actually with pinches and swipes, you can move back and forth like this, right? So that's kind of a swipe. You can zoom in with a pinch. You can, I'm sorry, zoom out. You can zoom in, right, to look closer. So it's kind of it's kind of taking some of the things you wouldn't normally get in the spec end because it's an Android app. It allows you to kind of take advantage of those. It also has what we would call a channel mode, right? And what that does is now allows you to pick technology, band, channel. In this particular case, we've picked band 13, which is one of the typical 5230s, one of the typical channels used across the U.S. It's a 10 megahertz signal. And again, you have all those same kind of capabilities, you know, zooming and panning. And the channel decoder, in this particular mode, since you're in channel mode, if you turn it on, what you'll notice added across the bottom is all the typical scan values should come up as soon as I hit apply. So now down there, not only do you have like the integrated signal power, which you'd normally have with a signal analyzer, a spectrum analyzer, now you have the channel power, you have the PCI, the RSSRP, the signal-to-noise ratio. So those are all available at the same time as you're getting a look at the spectrum. And it has all the same types of features you'd expect to see. Min hold and max hold are available. You can take a picture. You can also go through and have markers. And again, the value here is not that it's the best, newest, no one had a signal analyzer. What's nice is it's in your kit. If you have a scanner for walk testing and you have the SeeHawk Touch, it's tightly integrated. It's available. Switch back and forth real quickly and easily to kind of investigate what you need to look at. Okay? So back to kind of finish up on the presentation here. So essentially what we've done is, as I said, we worked real closely with a lot of guys watching what they did, and we identified a way to produce a tool that really gives them the features they need, according to spot testing, but actually and also achieve the the biggest priorities for producing a new tool. What's going to make me want to change my process, adapt my process, roll something out across many markets and hundreds of people? Can you really reduce the time we spend? Can you make it more efficient? Can you make it more reliable? Less capital investment, all these types of things, and really help us achieve a standardized process. And so what we found is there's a number of people already starting to use this and really able to see these types of value being added. Okay, so I think I've tried to squeeze that in 40 minutes or so. As a presenter, you always skip a bunch of stuff you wish you could say, but my marketing guy says, say less, say less. So we've kind of covered everything now. We're ready for questions if there's any questions.
Yeah, so I do actually, there was a few questions that I'm going to shoot your way here, David. The first one is, what is the difference with other suppliers, Neat Nemo, SeeGull, et cetera?
So first of all, some of the similarities, I think a lot of those people you named have integrated with IBwave. I think we were probably one of the first ones that brings that transmitter information over, and as an editor, I'm not familiar with anybody doing that yet. I hope, I wouldn't expect most people to start working on that. I'm not sure anyone's really, produced something that uses our scanner like this that I'm familiar with. But again, it's a pretty standard way of working, so I'd expect to see people do it. I think the biggest thing here is many of these test activities, the scanner is not only sufficient, but it's actually preferable. So a lot of these activities, all you really need to take out the day you go to do the baseline survey of the uplink and downlink is really a scanner. So if you want a simple, easy-to-use tool that's really focused on scanner measurements to get the job done, both our walk test and our AVT test and the signal analyzer really leverage the value of the scanner and get the most out of it and present it in a way that's relatively easy to use and to create good documentation.
Okay, great. Okay, the next question is, can you take a picture while in the field to associate with the location of the test?
Actually, if you're talking about like a photograph of the building, No, we don't have that integrated. A lot of times that's done in the IBWave tool itself. So if you brought it to Note, so if you're really focused on the planning process, that's where you would take advantage of their capabilities to document the plan with photos. So we're really mostly on the measurement part of it. On the other hand, a different way of kind of answering some of this is there's some things, everything we do you can document. I mean, of course, not only does Android have built-in, picture taking, but the signal analyzer allows you to take a photo right within the app, as well as all the stuff that I showed you in walk testing, and as of our April release in the AVT is all completely playback. So one of the nice things about this is really to try to get the field crews and the office crews working as efficiently together as possible. So we have features in ours like automatic FTP upload. So as soon as you're done one floor of AVT, that's gone back to the office on a server somewhere. So a guy who's in the office can sit there and immediately look at replay. So you can see all the antennas he tested. You can look at those same graphs and charts and see if there's problem areas and ask him to do some more testing in that area or go do some specific testing on that one antenna. So in terms of making the information easily usable, so you can play back photos within Android and those kind of things. So I'm not sure if I answered that two ways. Hopefully I got the question answered.
Okay, great. Okay, another question that we had, if you wait until the DAS signal sources are installed and operational, LTE, CDMA, etc., construction is long done on DAS. Isn't it better to find these issues early in the process while construction is still underway, e.g. using CW test gear?
Yep, absolutely. That's a perfect point. If you kind of go back to the earlier slides that I had, I'm trying to get back there now. That's kind of what this first intro about the different test activities were. So you see the first two lines were input into the planning process, but this third line is really about, you've built the DAS stuff. Let's do some testing at that point to kind of find out whether you can accept the installation is complete and finished. So that's where you test downlink and uplink using CW transmitters, right? So you put a CW transmitter in the head end, you walk out under each antenna, and you make sure that the right level's coming out based on what you put in. Same kind of thing, you put transmitters out at the remote head end, you go up to the head end now and use either the signal analyzer or the AVT with a regular scanner, do port-to-port checking, and look for noise floor, noise rise, all those types of things. So yeah, you definitely, the answer is yes. Much more efficient to do it that way. And then, of course, you know that when you go test later, after the equipment's hooked up, if you find problems, it's not in that first set of activity that was done with the construction. Yes.
Okay, great. Okay, a few more questions here. The next one, will it be possible to feed walk test data from a benchmark survey into the AVT?
That's a good question. And so what we have today, no. But what we have found is that while there are times that says, I really don't want to do a complete walk test, and I don't need it, and it wouldn't be productive because I'll expect to find problems with spot testing. So if I hit each antenna, I expect to find enough problems, then it wasn't worth my time to do a walk test. At other points, later points, let's say you still want, now you're ready to do a full walk test, but you might like to have AVT-type results as well. So one of the things we're planning for a future, evaluating for possible planning for a future product would be you can do a walk test. As you're at each antenna, we capture it and store it as an AVT format. So now you can actually kind of get both those done at the same time. So again, now you're kind of like, you're late in the process. The cell site equipment's basically working. You did your initial commissioning work. Now you're ready to do a walk test to kind of verify the whole system, but I still want AVT-type results. Yeah, so if that's the question, that's something we've seen, we've heard about, and we're kind of evaluating for a future release of the product.
Okay, awesome. Okay, next question. Can AVT address the uplink part of commissioning?
Excellent question. So one of the things, so again, now the commission now is you've kind of already hooked up your cell site equipment. So what we do now for downlink, you know, you make real scans, you look for RSSRP, RSSRQ type measurements on the downlink, and okay, so now you've got that done. So what we've been asked to add, and we're in the process of adding it now, is to integrate a test mobile to do some basic tests. And the theory kind of goes like this. If your downlink measurement's good and it kind of meets your design and there's no noise, there's no, you know, so the interference looks good, so the noise looks good, that when a phone is interacting with the network equipment and everything's been adjusted and levels have been set, you expect him during the course of using, like downloading his file or having a call up, you expect him to have certain transmit uplink power, right? You expect to be within a tight range. If that's there, then you can pretty much be sure that your uplink is relatively good, your uplink path is good. If it's not, that kind of indicates a problem. It doesn't tell you what the problem is. There you'd have to probably go to the head-in, switch to your signal analyzer, kind of look for other types of things that have gone wrong. But essentially what we are producing or providing in our next release of the product is an uplink test for that commissioning phase.
Okay, great. All right, 2 more questions here. So you got 5 minutes for these last 2 questions. Do you have a way to automate the signal analyzer based tests in the head end?
This is all sorts of great feedback on how to, one of the things we found, just a general statement first, is we're getting a lot of good response to these things, but we're getting as many questions for improvement as we are anything else. So this is another one of those things that we're looking at closely. We've heard requested multiple times from people who are using this. So we're looking at 2 types of things. One is when you're actually in that signal analyze view that I showed, to actually be able, so we already have a bunch of the ability to save settings. So if there were 4 channels you're going to measure, you can save those 4 settings, switch between them real quickly manually, and be able to take a picture. But one of the things that we're thinking about doing is integrating that with the AVT. So now if it's the AVT, what you want, instead of just basic scanner measurements, you actually, each time you touch an icon, you want to bring up one channel after the next, say all 4 of those or 5 in the list, take a picture and then move on while you're at a given port, then move to the next port and repeat that process. So we're looking at finding a way to integrate the AVT controls of the signal analyzer capturing pictures. So it's a good question, and I think it's one that I think a lot of people would find valuable. So I hope to be able to get that done at some point in some future release. No promises, no dates yet.
All right, now the last question. What types of network build or configuration issues can be detected by AVT, and will it have suggestions for resolutions to common problems?
You know, some of this kind of already been thrown out a little bit in one of the earlier questions to talk about. So let's talk about, you just put a bunch of DAS, you put the antennas out, you run the connections, the remote head-ins, the amplifiers, whatever. All sorts of things can go wrong anytime you're building anything, right? Particularly from the guy who did the plan to the guy who's doing the install. So really there's a variety of things, either not, connectors not tightened, dirty, dirty connectors with shavings in it, things being misconfigured, hooked to the wrong port, things not being connected. I was out on one test, we were walking around, we realized one antenna didn't look good on the AVT. We looked up and the antenna had been dismantled. It was only half there. So all sorts of things about how the construction and the installation configuration was done. Same thing after in the commissioning phase. You've hooked up the base station equipment. You're looking to see the right PCIs are there, the right signal levels. If there's been anything done in such a way to introduce noise, interference, of things like that. So there's a wide number of things that can be detected. Some of these things are easier to kind of hint at. Clearly, we've talked about we can identify the right PCI, the wrong PCI. If you're under an antenna and you expect PCI 10, but you're getting 15, well, it can be a number of reasons, but if you recognize 15 is the outdoor PCI, well, then maybe your antenna's off and you're not picking them up and you're picking up the outdoor one. Or if the design wasn't done well, something went wrong with the design and the dominance isn't good enough. So those are the types of things you can kind of get an idea what the problem is. There's others that just tells you need to go do some more investigation. If you see a bad signal-to-noise ratio, there's interference somewhere, but we're not necessarily giving you a hint as to what it is. That's where you need to bring out some of the tools to kind of finish troubleshooting. The signal analyzer is often very helpful in something like that. Maybe other tools as well, pen testers, et cetera. Okay?
All right, great. Well, thank you so much, David. I really appreciate everything and what you've shared with us over the past hour. For those of you still on the call, we will be sharing this presentation, so you'll get a recording, and then we'll also be sharing the actual presentation as well. So if you have any questions or if you want to get in contact with anyone from PCTEL to learn more, you can email David or myself. My email is info@nedas.com, and I can get you in touch with the right people.
Thanks so much for having me, and enjoyed being here.
Awesome. Well, thank you guys. Everyone have a great rest of your day.